All right, now that we've had our short break, let's continue with where we left off. Um, we now proceed to question 12. Question 12 says that each side of a large square is divided into three equal parts. As you can see in the figure, each side is divided into three equal parts, and some of the lines are joined, and the area of the small shaded square is 9. So you have a kind of a tilted square there. And the question is, what is the area of the large square? All right, so the question is, you got the area of the small square, and you want to find the area of the large square. So how do we do that? How do we do that? Well, we know that the area of the small square is 9. So what does this mean? It means that each of the sides here, let's just get the black onto this. It means each of the sides of the square here are all 3. Okay. Now, I just want to point out here that we don't know the area of the large square. All we know is the area of this little square. But suppose each piece here is x. Well, all the sides have been divided up into 3 equal pieces. So I'm going to just write down x here up to a certain point. Okay. Now, these 3 are all equal. You see, this is 3. Now, why are they all equal? The reason for that is that you have that this line, you see this figure here. It's a parallelogram because the opposite sides are equal and parallel. So it's parallelogram. So it means that these 2 lines are parallel. And likewise, these 2 lines are parallel because this figure here is also a parallelogram. So what you've got here is you've got a triangle. If you take this triangle here, you see you've got lines which are parallel and these are equal. So therefore, automatically all these will be equal. It's called the intercept theorem. And if all these are equal here, then these are automatically equal because these lines are parallel. Okay, now we need to find the area of the large square. In other words, the area of the large square, according to, well, if we named this x as it were, it's a square of the side, and the side, each side is 3x. So we are looking for 9x squared. This is what we need to calculate. In other words, we need to calculate x first. Once we know x, then we can calculate 9x squared. So how do we go around doing that? Okay. Now, we can isolate. You see, one important thing is that this angle here is 90 degrees, where these 2 lines intersect at 90 degrees. It looks as if it's 90 degrees, but what's the reason for that? Okay, I'm going to do this in the next picture. You'll see it'll be much clearer why that is 90 degrees. Actually, most people will just assume that this is 90 degrees without thinking about it. But in good mathematics, we have to ask the question, why is that 90 degrees? In other words, why is this line here perpendicular to that line? I got a 90 degree in this picture here. But why is that so? And the answer to that question is the following. You see, if you look at this triangle here, the sides are 3x, x, and 90 degrees, and you got a 90 degrees in between. Right? Now, one of the angles of this triangle is this angle here, which we are calling theta. Now watch, if you look at this triangle that I'm drawing, that's also got x, 3x, and 90 degrees. So these triangles are congruent. So therefore, that theta there must be is the same as this. So I've written it down. These two angles are theta. Right? Now, if you take this angle here and you add it to theta, you're going to get 90, right? Because in this triangle, that is 90. So theta plus dot is 90. So therefore, in the small triangle, theta plus dot is 90. That explains why this is 90. Okay. Now, I'm going to isolate this thing here, this triangle, and I've redrawn it here. Right? Just this triangle here. I'm trying to calculate x, so I'm going to focus on this. It's got a lot of x's in it. You can see this is going to be 3x. That part there is x. I'm redrawing this triangle here. And there you have the theta, which we spoke about earlier. And we also have that this 90 degrees. We just proved that. Okay, so you've got a 90 degrees here. And you got a 90 degrees here. And now I say that the cosine, you see, we need to calculate 3x. If you look at 3x, it's a side of the red triangle. It's a side of the red triangle. What do we know about the red triangle? We know that this side here is 9. You see, it's the same as this. So, and this is the adjacent side for this red triangle as far as theta is concerned. And 3x is the hypotenuse. So, cosine of x can be calculated. Cosine of x is 9 over 3x, right? As you can see. But now theta is also an angle in the large triangle. And there, in the large triangle, the 3x now becomes the adjacent side. No, yeah. 3x becomes the adjacent side, and this becomes the hypotenuse. Right? But this hypotenuse can be calculated because I've got the other two sides are 3x and x. So you can work out in the large triangle, cosine of theta is 3x, which is the adjacent, over the hypotenuse, and the hypotenuse can be calculated using Pythagoras. Pythagoras says that the hypotenuse is the square root of x squared plus 3x all squared, which is 9x squared. Now if you simplify this, this is square root of 10x squared, and you take out the square root of x squared, and you have x, actually you have 3x over x root 10, like that. And this is 10x squared, and then the x's cancel. That's how we got a 3 over root 10. So now you have, if you look at this part here, you got 9 over 3x equals 3x over 10. So you have an equation. See? 9 over 3x equals 3 over root 10. So if you cross multiply, but 9 times root 10 is equal to 3 times 3x. That x hasn't gone. These x's have disappeared. Right? They cancel. Let me just take it out for clarity. So that x there is out. Right. So when you cross multiply, you have 9x equals 9 root 10. 9's cancel, you got x equals square root of 10. And remember, we were trying to calculate 9x squared. So if x is square root of 10, then 9x squared is 9 times 10, which is 90. And that is the area that we're looking for, the area of the square. So it's not an easy problem. It's quite a challenging problem. There's a lot of geometry involved in it. In most cases, they would just expect you to assume that all these lines are equal and assume that this 90 degrees, it looks like it. But as I said, in geometry, you don't do that. And for completeness, I explained why those things were 90 degrees. Okay, so let's get on to the next problem. The next problem is problem 13. Problem 13 says Ellie spun a coin 30 times, right? Whenever the coin showed heads, Ellie gave 2 of her sweets to Pabetse. So Ellie and Pabetse are playing some kind of a game, and they toss a coin. So let's see what's going on here. Ellie and Pabetse. Okay. So whenever the coin shows heads, Ellie gave 2 of her sweets to Pabetse. So she lost 2 sweets, while Pabetse gained 2 sweets. Whenever the coin showed heads. If you continue to read, when the coin showed tails, Pabetse gave 3 of her sweets. So Pabetse, she lost out, and she gave it 3 of her sweets to Ellie. All right. Now, after 30 spins, both Ellie and Pabetse have the same number of sweets. Okay, you got 30 spins, but you don't know which is a head, how many heads and how many tails there are. So the question says, how many times were heads spun? So that's the question. Okay, so why don't we let x be equal to n be equal to the number of heads. So we need to calculate n. How many times were heads spun? All right. So if there were n heads, each head, let's see what happened to Ellie. So what happened to Ellie was that Ellie lost 2n sweets. Because for each head, she lost 2 sweets. So after n heads, she lost 2n sweets. Now, the coin was spun 30 times. So if there were n heads, the remaining ones should have been tails. So how many tails are there? Altogether, there were 30 spins. So there should have been 30 minus n tails. Right? So Ellie lost 2n sweets, but she gained by the tails. And Ellie, she gained. Now, how much did she gain? For each tail, she gained 3, but there were 30 minus n tails, so she would have gained 3 times 30 minus n. Okay. But now we say that after 30 spins, both Ellie and Pabetse had the same number of sweets. Now, what does that mean? As they started with. So it means that whatever Ellie lost, she gained. In the beginning, whatever she had in the beginning, after 30 spins, she had the same amount. So whatever she lost, she gained that back, which means that this 2n is the same as 3 into 30 minus n, because that is what she gained, and this is what she lost. And these two must be the same, because she's got the same number of sweets that she started with. Now you got a nice equation here. 2n equals 30 minus n, so it's 90 minus 3n. So 2n is equal to 90 minus 3n. Bring the n to the other side. 5n equals 90. N equals 18. And that is exactly what we needed to find. How many times were heads spun? And the answer is 18. Okay, so let's get on to the next problem. We go to problem number 19. So there you are. We're going to problem number 14. We did 12 and 13. Right, now, problem 14 says, none of the learners in a certain school know the rules of Sudoku. This is a game where you have numbers adding up to 9. So nobody in the school knows the rules for this. On the 15th of January, a teacher teaches these rules to 3 learners. So 3 learners now know Sudoku. Right. Now, every day after this, in other words, on the 16th of January, for example, every learner who has already learned the rules teaches them to two learners who did not know them yet. Okay, so each of these 3 people, they know the rules. They taught the game to 2 new people, So now you've got those 3. The new people are 6, right? So then 6 new people know it on the 16th of January, right? So every day after this, every learner already learned the rules. So on the second day, you have 9 people know the rules. Right. On the first day, 3 know the rules. On the second day, 9 know. On the third day, the same thing happens. Each day, everybody who knows the rules teaches it to 2 other people. Now, there were 9 people who knew it on the day before, so each one of them would have taught it to 2 people. So you got 18 new people, right? So altogether, how many people know the rules? Together with the people who learned it on this day and the ones who knew it already, so you got 27 who know the rules. So you can see what's happening here. You can try it out and you will see you got 3, 9, 27, and it keeps multiplying by 3. So the 18th of January, it will be 81. And the question is, how many know the rules on the 20th of January? So that's not difficult now because you simply have to multiply by 3 each time. The 19th of January, you got 243. You have to multiply that by 3. And on the 20th of January, that's when we need to get to. You have to multiply this by 3. You get 729. So the question is, how many learners know the rules by midnight on the 20th of January? And the answer is 729. So the idea is each day you look at the what's given and try to find out, because we need to know how many know the rules on the 20th of January. So each day you find out how many know the rules and you see a pattern coming up, and that leads to the solution, which is 729. So let's get on to problem 15. Okay, so this is 15. Problem 15 says, a square ABCD has side length 60. Okay, you can see there's a square here, and the side length is 60. So let's record that information. All the sides are 60. And then a triangle CDE is drawn. Oh, you got CD and you got E up there, but they got equal areas. The area of this is equal to the area of this. Okay, this area here we already know because it's a square with side 60. So its area is 3000. 60 times 60 is 3600. So we know that area. So we are saying that the triangle and the square have equal areas. So if this area is 3600, this area is also 3600. They got equal areas. And the question is, what is the distance from the point E right down to the bottom? Extended line AB. So the problem is, what is this distance? All right. Now, that shouldn't be too difficult because, you see, we know how to find the area of a triangle. The area of a triangle is half base. So the 3600 is the area of the triangle. It's equal to half the base, which you can see is 60, times its height. But what is the height of this triangle? Well, the height, if you take the height from E, I have to extend this line here. And this thing here will be the height. Well, let's give it a name, H. So the area of the triangle is half 60 times H. But now you have a simple equation. Half of 60 is 30 times H. So you got 3600 on one side and 30 on the other. So you divide these two, the tens cancel, 3 goes into 3600, 360 is 120. So this part here is 120. And we need to know the whole thing, but we already know that this is 60, you see, from here to here. So there we have it. This question mark will have to be 120 plus 60, and that is what we are looking for. The distance of the point E to the extended line is that. No units are given here. They're not saying centimeters or anything. So you just say 180. So that's the answer to question 15. All right. Now, the next question. Let's just go to problem 15. Now, problem 16, I'm going to put a hold on that. Problem 16, I've taken it out from here. It's a problem involving a logic. So two people are together, one is speaking lies and the other is speaking the truth. We'll do that in session 2. Let's do problem 17 for now. See how far we can go. What is problem 17? Problem 17 says you got a quadrilateral ABCD. Its area is 60. So you're given the area of this entire quadrilateral. I'm not going to write it down, but we know this full area is 60. And you have an inscribed circle. You have a circle which is inside it of radius 3. So this circle here, we know its radius is 3. And the question is, what is the perimeter of this triangle? Right. So you know the area of this triangle, you know the radius of the circle, and what is the perimeter of this. Now, at first glance, you'll say, what the heck? How are we going to do this problem? When you think about this, you'll say, well, look, I know some things about tangents because all these are tangents to this. And I know some facts about tangents. What are the facts you know about tangents? I'm going to show you what facts you know about tangents. So then we can use these things. So there are two important tangent theorems. In fact, there are three tangent theorems, but for the time being, we will look at two of these theorems. The one theorem says that if you take a tangent, it touches a circle at exactly one point, and if you take that point and join it to the center, that line is always perpendicular to the tangent. Right? That's the first result on tangents. And the other result on tangents is that if you've got a point outside the circle, outside a circle, then you can draw two tangents. It turns out these two tangents are always equal in length. Right? In my book, I explain why these are true. Why is this perpendicular? And I explain why these are equal. So if you go to my book, I think all of you probably have the book, 1000 Mathematics Olympiad Problems, and go into the geometry section, you will find out why these are equal. But I can prove it very quickly here. The reason why they are equal is, suppose I've got these two tangents. I'm not going to say they are equal yet. And then I join these as we have got there. And this means that this radius is perpendicular here. And this one is also perpendicular. Now, if you look at these two triangles, right, you will see that they are congruent because this is a common side. And you got this side here. And you got a right angle. So this is right angle hypotenuse side. And therefore they are congruent. And because they are congruent, these will have to be equal. You see? That's why these are equal. Okay, we're going to use these facts here to find out, to solve this problem that we just had. Okay, so let's go back to that one. Okay, now what I'm going to do is let's go to this. Yeah, okay. So to solve this problem, it's natural now from what I've just said to join the center of the circle to the points of contact, because we know that these lines are perpendicular. So I'm going to join the center to that. Now we know that's perpendicular. And here too. So I'm joining this to the points of contact. Okay. And all these are radii. It's gone off a little bit. And we know that the radius is 3. So I can actually write down 3 here, 3 there, and 3 there. All right. Okay, and these are all 90 degrees. Okay. Just one moment, I'll be back. Okay, I'm sorry about the break. Okay, now the area of this triangle, this quadrilateral, is a rather odd shape. We know it's 60. And from this picture here, you can see the area is going to be equal to the sum of 4 possible areas. So you got the area of 4 quadrilaterals, right? So let me try to work out the area of each of these quadrilaterals. Now, if I take this quadrilateral here, right, we don't know a formula for the area of a quadrilateral. We know the area of a square or a rectangle, but generally any quadrilateral you don't know. But in this case here, you can actually calculate the area because you've got a right angle there, see? So all we have to do is join a diagonal, and then that should give you 2 right angle triangles. I'm going to join this diagonal like that. And now you'll see that this quadrilateral is now divided up into 2 triangles, and both of them are right angle triangles. So we should be able to calculate the area of that triangle. All right. But now, before I proceed with that, I needed to find the perimeter. The question, let's just concentrate. We needed to work out the perimeter of this triangle. And the perimeter is going to be AB plus BC. It's the sum of the 4 sides. That's what you mean by perimeter. So this is the question. What is AB plus BC plus CD plus DA? Okay, so we don't know that, but what we do know is that these two are equal. We just said so. They are points, they are tangents from a point outside to the circle. And likewise, this, so I'll call them A, little a shooting out from capital A, and I'll call this little b, which is shooting out from capital B, and these, call this little c. They're all equal because, from what we just said, from a point outside the circle, if you draw 2 tangents, they got equal lengths. So now, bearing that in mind, if you name them like that, then we can see what the perimeter is. The perimeter is going to be A plus B plus B plus C plus C plus C. So let's start from here. A plus A, this is a starting point, plus B plus B plus C plus C plus D plus D. So we're back to the starting point. So this is the perimeter. So, well, that's 2 can come out into A plus B plus C plus D. So the problem now is to find out what is A plus B plus C plus D. Remember, we haven't used the fact that the area of the quadrilateral is 60. We haven't used that yet. Okay, now let's calculate the area of each of these and add them up. Then we will know that that is equal to 60. We know that the sum of the area is 60. So there, in that case, we might have an equation, or we will have an equation. So the problem is now to find the area of this quadrilateral. This quadrilateral has got 2 pieces to it, right? As we said earlier on, and each piece, if you take this piece here, the area of that is a half base, which is 3, times the height. It's a right angle triangle. So the area of this piece is 3a over 2, or half of 3a, a half of 3a. But this piece here, also the area of this is half of 3a. It's exactly the same triangle. So therefore, you got another half of 3a. So the area that you're looking for is twice this. So it'll be 3a. The area of this quadrilateral, this is half of 3a, this is half of 3a. So the area of one of those quadrilaterals is 3a. So this, one of those is 3a. See, that's the one here. Now, if you take this one by exactly the same argument, it'll have to be 3b. And if you take this one, it'll be 3c. And if you take the last one, it'll be 3d. Okay? Because the area of each quadrilateral is 3 times the side. So you got 3a plus 3b plus 3c plus 3d is 60. If you divide right throughout by 3, or otherwise you can take out 3 as a common factor, right? Then you'll have that a plus b plus c plus d is 20. So we've got this. Some kind of a magic here. We landed up actually calculating this without knowing what a, b, c, d are. We only needed to know what a plus b plus c plus d is. And that is 2 times 20. And that gives you 40. And that's the perimeter. No units are given. So we just leave it as. So that was what we needed to calculate, the perimeter. And the answer is 40. Okay, we will stop there because the time is up. And we had planned to go up to problem 20, but we'll have to postpone that till next week. So next week, we will do so next week we will do we missed out 16 earlier on. I told you we'll do that next week. And then we went up to 17. So we'll do 16, 18, 19, and 20, plus whatever we had for session 2. Okay, you've already got the questions for session 2. I don't know whether you got it, but you can add these 4 questions to that session. So we're going to have a longer meeting, or otherwise we'll cut out some of the questions of session 2 so that we can complete that in time. Okay, but what I will do is I'll prepare new questions, a new set for session 2. I'll prepare it and we'll post that on the website. Right, and for next week now, I think you know by now that you have to read and try the questions on your own before you come into the class. Today, I noticed that we had almost 98 students, but it was quite clear that about 47 or 48 of them, maybe about 50, had actually tried those questions, because those were, each time I asked how many people answered this question, I always got less than 50, even if the questions were easy. So it doesn't help. Those remaining 48 students who came to the class, they are seeing the questions for the first time and seeing the answers straight away. So where's the learning process? Right? Mathematics is not done that way. So please try to do the questions. If you fail, that's fine, but you know, at least you know you tried. Okay. And round 2, the problems are quite difficult, as you can see, because eventually only the top students from round 2 will be allowed to go into round 3. But you all can try. Every one of you has got the potential to get into the top 100. Okay, you passed round 1, and that was quite a hard test by itself. So thank you very much. I will see you next week. And in the meantime, have a wonderful weekend. Thank you.